Hi everyone, welcome back to my channel and thank you so much for joining me this week. So this week I'm going to be using Manus to generate some inquiry-based inductive learning experiences for middle school for Romanian teachers. And I'm going to show you the results. Now, if you were with me last week, you saw me generate ideas using Gemini, DeepSeek, and Claude. And who was the true winner out of those three? There wasn't one. So let's see how Manus actually handles this task. If you're interested in seeing the results, then please keep on watching. Okay, so let me just show you what the prompt was that I used for all three models last week. Okay, so last week I meta prompted and I asked whether Claude Sonnet could give me a really comprehensive prompt to input into an AI model that is about giving 10 suggestions for middle school inquiry-based inductive mathematics learning experiences. So it gave me, as you can see, a really long prompt. So you can see, I went through this last week and you'll see it's quite comprehensive. And the only thing that I forgot to put in the prompt was that it was for Romanian teachers. So shall we see what Manus has come up with? And just as an aside, last week I did use this exact same prompt for Gemini, DeepSeek, and Claude. And I found that Gemini is hallucinating a little bit more because I did ask Gemini in the Romanian curriculum, where do students learn about the trigonometric ratios? And it said something like year 9. And when I asked my friend to look up the actual standards, it was year 7. So, Gemini's not coming out on top at the moment with my tests. And then to save time, I've already asked it to generate it, but it probably took 2 minutes, to be honest. So I've generated a comprehensive curriculum guide with 10 highly detailed classroom-ready, inquiry-based inductive learning experiences tailored for Romanian middle school maths educators. The guide is written in a professional academic tone, utilizing structured tables, diagrams, and formatting aligned with your exact specifications. It includes cultural hooks, which I love, such as traditional Romanian embroidery. And I don't know how to pronounce this, but it's a historic clock tower. There's real world data, Carpathian weather, and Bucharest taxi pricing, physical manipulatives, and dynamic geometry technology. Now, last week when I used DeepSeek, Gemini, and Claude, they didn't give me anything that was in the Romanian context. So I'm happy to see that Manus has actually given me something with the Romanian culture taken into consideration. So let's just open this up and go through some of the activities. So here it's given me a really nice overview of the 10. These are very creative ideas. I mean, I'm sure that there's going to be a tiny bit of overlap with last week's output and ideas because you can only go so far with pi, right? I mean, there's only so many explorations you can do with pi. But I like so far the cultural angle that Manus has taken. So let's just have a look. Traditional Romanian flaws, looking at GCD and LCM. So I'm just going to have a brief read of this. So it's about greatest common divisor and least common multiple. So we actually call that greatest common factor and least common multiple in other parts of the world. Inductive inquiry hook. Students are presented with a scenario where a local artisan wants to tile a rectangular floor using only square tiles of traditional Romanian ceramic designs. The catch is the tiles must cover the floor perfectly without any gaps, overlaps, or cuts. Students receive cardboard rectangular floors of these particular dimensions, along with a set of square paper tiles of various lengths. They are asked to discover which square tiles can tile each floor perfectly and find the absolute largest tile possible. Oh, I like this. So students examine their recorded table. They work in pairs. I love how there's promoting some collaboration. Let's go to the first step. Working in pairs, students physically place different square tiles onto their rectangular templates. They record their findings in a structured table, noting which tile size fits perfectly and which leaves gaps or spill over the edges. Nice. Okay. So generalization is that students write down the rule in their own words, explaining how to find the largest square tile for any rectangular floor. The teacher then introduces the formal technology, greatest common factor, and here it's written in Romanian. The other language models did not give me anything to do with Romanian, even though I added that word in. And the teacher then transitions to a second puzzle. If we lay a border of red tiles, each 4 centimeters long, alongside a border of blue tiles, at what distances will the seams of the tiles align perfectly? And this leads to discovery of least common multiple. And it's got some teacher questions, collaborative structures, formative assessment, differentiation. I like it. Now look at this one. This is a lot more. I mean, of course, we look at growing patterns always, but the last 3 models last week were giving me very generic explorations. This is talking about growing folk motive and taking into consideration the cultural aspect of Romanian cross-stitch. So let's have a look at the inductive inquiry hook. Students are shown a sequence of 3 growing traditional Romanian cross-stitch motifs, often found in traditional shirts. The first pattern consists of a single red square surrounded by blue squares, blue wing squares. The second pattern retains the central red square but extends the blue squares, etc. Okay, so, leading to some algebraic generalization, but, really taking into consideration the Romanian context and culture. I love it. I love it. This is so much better. Manus, I don't know when you're going to disappoint me, honestly. So let's go on to, there's 10 different ones. So let me just, so this video is not so long. Let me just quickly go through. So this is triangle angle sum. Okay, we've seen lots of different versions. This version is looking at a GeoGebra applet. Okay. And then students try to break their conjecture. They're making conjectures, right? So I'm looking at number 3. They attempt to construct a triangle in GeoGebra with a sum of 179 or 181. They also draw extreme triangles, almost flat lines, to see if the rule holds, okay? So you can only do so much with the angle sum of a triangle, right? Like either you tear the 3 angles apart and then paste them along to form a straight line, or you use a GeoGebra applet, but it's got some great questions here. Okay, pi, this is what I'm interested in because there's only so many explorations you can do with discovering pi and the ratio of circumference to diameter. So this one at least is looking at a variety of cylindrical objects in Romanian households, such as jars of sucuța, I hope I'm pronouncing it correctly, and some other Romanian household objects. And then we've got the exploration in small groups. Students select 5 different cylindrical objects. Of course, they're using string again, I can see, and there's only so far. I think I would add to this that it's a linear function, so I'd get people to graph all their different circumferences with diameter and see that it's a linear function. Okay, but at least they're incorporating the Romanian context. Okay, this is measures of central tendency, so this didn't come up in the other 3. Carpathian weather analysis. So this is about mean, medium, and mode, range and outliers. And it's even tells me it's part of the statistics curriculum. So what's the hook? Students are shown 2 conflicting headlines about the climate in the Carpathian Mountains. Average October temperature in Brezov, I've been there, by the way, is pleasant 10 degrees, perfect for outdoor activities. Visit Brezov, October weather is volatile. Averages mislead tourists. So the teacher asks, how can a single number represent an entire month of daily temperatures? Is that single number always reliable? Is it always a reliable guide for what to pack? That's a really good hook. And so now students are provided, let me just scroll down, with a real data set containing the daily high temperatures for Brezov during October and January of the previous year. They work with spreadsheets. pattern recognizing, conjecturing. Students are asked to find the middle. I mean, this is really good, actually. I think I might include this one and write this up for students because it's so relevant. Instead of just finding the mean, median, and mode of just, I don't know, any numbers that don't have any relevance, we could do this. So we've moved away from taking physical measurements of students to use as data, but this is a great one. All right. And we're only halfway. So, this is the laws of exponents. So this is quite standard. I think this is the same, but at least this tells me where in the curriculum it is. Okay, it gives you a nice table. So that's the same as what Gemini gave me and DeepSeek and Claude. The Bucharest taxi dual systems of linear equations. So this is looking at taxi company A charging a flat rate and then taxi company B charging another rate. So great. Okay. The area of the tilt. So this is from rectangles to parallelograms. So students are given grid paper showing standard rectangle. They can easily count the grid squares to determine the area. Next, they need to see a parallelogram with a base of 6 and a slanted side, but no grid lines. So the teacher asks, how can we find the exact area of the tilted shape? We cannot easily count, okay? So the exploration, students draw an identical copy of the parallelogram on the grid and using scissors. Yeah, this is exactly how I would help students to find the area of different quadrilaterals, always decomposing the quadrilateral to a rectangle. Beautiful. Okay, nice activity. Now I don't know how to pronounce this, but I think it's a clock tower and it's the shadow. So, oh yeah, there it is. The teacher displays the image of the famous clock tower in the medieval citadel. Okay, and the teacher asks, how could medieval builders measure the exact height of this massive tower without climbing to the top with a giant measuring tape? Could we use the sun? This is really good. Look, on a sunny day, the teacher takes the class outside, work in groups, students stand a standard meter stick vertically on the ground and measure the exact length. So we're actually using similar triangles, proportional reasoning, etc. Fantastic idea. Okay, what's the last one? Because this video is getting too long, but they're really good ideas. The carnival swim, theoretical versus experimental. So this activity looks at the law of large numbers. So as we increase the number of trials, experimental probability approaches theoretical probability. And let's just read the inductive inquiry hook. The teacher introduces a simple carnival game. Roll a standard 6-sided dice. If you roll a 5 or a 6, you win a prize. If you roll a 1, 2, 3, 4, the house wins. The teacher asks, is this a fair game? If you play this game exactly 6 times, will you win exactly 2 times? Let's run the carnival and find out. Yeah, good hooks. I love it. So they'll have a table, I'm sure, to fill out. And yep, fantastic. And then look at the pedagogical guidelines for implementation. It gives me a side-by-side comparison of traditional deductive approach with inductive inquiry approach. Okay, I don't know how many videos I've actually made about Manus and how good the output is. It's a RAG model. It will do extensive research. It will also be a little bit more creative than other models. And I must say, the inductive inquiry learning experiences that I generated for middle school mathematics for the Romanian context are so much better. And actually, I've gotten a couple of ideas that I could use that I didn't think of. So thank you, Manus, once again. I still say watch this space. I think a couple of months ago, it used to be a Chinese model and it got sold and bought out by Meta, and the China government's trying to buy it back. So watch this space to see what happens. Thank you so much for joining me this week, and I hope to see you next time. Bye.